Mm-hmm.
It was probably the Haines that shot it. They like shooting bears.
Oh boy, they do it a lot. And somebody shot it and their entire family was looking for it. And I was like,
I know,
that's
and
a
then,
little suspicious.
and then they had like, their kids shoot it because they wanted to shoot another one.
Up at the house?
Yeah, they're at their house. The dad shot one and then he wanted to shoot another one, so they just made the kids shoot it.
Like legal hunt shoot or just
No,
shoot?
just shoot it.
Out by our house, one night we shot like 4 bears.
Yeah,
Like right after each other.
they just kept coming in.
Like they shot one bear and then another bear came to eat that one and said they shot that one too. And then there was another one, but that one left them alone for a little bit and then they shot that too. And I was like, that's a lot of bears.
On our shop, we have like plexiglass windows like 7 feet off the ground. And a bear like jumped up and smashed the window and just hopped in, grabbed a bag of trash and ran out.
They're pretty cheeky. It tore the wall off our shed 2 years in a row.
Well, yeah, you keep your garbage in the shed too.
We haven't had.
I mean, that's like, come on.
We
They're gonna do that, they're just gonna come in.
The only bear we've had is it just walked right between our truck and like our back door, and that's it.
We had one in our car one year.
We don't have.
Did you hear about that car when the bear got trapped inside and shredded it up?
Yeah.
That's what
It was like total on the inside, it was terrible.
Well, they don't do that because there's no reason to.
Yeah, no, it got trapped inside and it's like.
They figure out too, they get in the car once because somebody left food in it and they just think, well, cars have food in it. I mean,
I think the
They're
door
not
shut
stupid.
behind it and it like started to freak out.
yeah, well, they're gonna do that, then they're caged.
It ripped the handle off of Gable's new truck.
Really?
Yeah.
So
He
funny.
locked the door because he didn't want him getting inside and tearing it up. And then he got woke up at like the middle of the night and there was a bear running away and the handle was on the ground. And I was like, that sucks.
But there was a bear on Leslie a while ago that would just tear the door.
Fight the door handles out.
And we just left our car unlocked and went inside, like took a coffee cup and then closed the door behind it and it went.
We don't have bear
There's a big
problems.
bear out there. There's a bear out there that rival any bear in the borough. He's big, big, big.
We just put spike boards down on the ground in front of the shed and then electric fence in front of the door of the shed and then.
It's funny, this is the first summer that I've ever even seen a bear in my yard. But,
We get them all the time.
yeah, I don't know, it's weird, I know they come through, but. All right, so when you're multiplying and dividing rates, it becomes more and more important that we include the units. And the reason is this. Units will tell you whether you're doing your work correctly or not. That simple. The sooner you get used to putting units on your numbers and using that in your work, the better off you're gonna be, the fewer problems you're gonna have.
How do you put units on it without mixing up the letters?
Well, let's look at these and think about how they work. If we have something like an hour, how many minutes is that equal to? Equal to 60. And like a minute is equal to 60 seconds, right? So here's a couple of things that we can use. And you may recall I've taught you some of this, I've shown it to you at least, but it really should stick now. We gotta make it start sticking. If we were to take two things that are equal to each other, and we write them as a fraction, for example, 1 hour and 60 minutes, it's the same amount of time but different units. If we write that as a fraction, we have the same value on the top as we do on the bottom. So that whole fraction itself is like having 1 over 1, 2 over 2, yeah, it's equal to 1. So if I wrote 1 hour over 60 minutes, and that's a fraction, that's equal to 1, and I multiplied this, for example, by 120 minutes. So now I'm taking this amount that I have given amount, and I'm multiplying it by the number 1. My answer is going to be the same amount. Because I'm multiplying by 1, right? Any number times 1 is itself.
Yeah.
But when we put units onto it, and we multiply by a fraction that's got units on the top and the bottom, it allows us to have the same value over here, is what we started with, but written in different units. So if we look at this, before we multiply, we can simplify by taking minutes and dividing by minutes, which equals 1. Just like x over x equals 1. Now when we take this, we have 120 times 1, and then divided by 60. What does that equal?
Wait,
So the 120 divided by 60 is equal to how much?
2
It's equal to 2. So now the only thing that's left in this here is 2 times 1 times hours, which is 2 hours. So what we did is we took 120 minutes, and we used what's called a conversion factor. And we used that conversion factor to change the minutes into the same amount of time, but written as hours. Factor is a number that's used for multiplication. So this is a number that gets used for multiplication to convert units. That's what a conversion factor is. And we can write, an unlimited number of conversion factors. As long as we know two quantities are equal to each other, we can write that as a fraction. So we could do a minute and 60 seconds, like so. We could also write it like this. We could put the seconds on the top and the minutes on the bottom. You can do things like, 4 quarts and 1 gallon. They're equal amounts, so we can write a fraction like that, and we can use that fraction for multiplication. 1 mile is 5,250 feet. I'm sorry, what am I saying? 5,280 feet. 1 mile is 5,280. And you could write that fraction upside down too, say 5,280 feet over 1 mile. And all of those can be used for multiplication. So in the first example, they say on average an adult human heart beats about 70 times a minute. That's your pulse rate, about 70. At this rate, how many times does a heart beat in a 365-day year? So we know we gotta just, it's 70 every single minute. We gotta add up all of those minutes to figure out a year's worth of heartbeats. So it's gonna be a pretty big number, isn't it? And a way to do this is with conversion factors. And by using units and conversion factors, we can be more certain that we have the correct value at the end. So heart rate, 70 beats per minute. How many beats in 365 days? That's our question. So this is a rate, 70 beats per minute. And we need to actually just change it to beats per year, which would be another type of rate. So we start by taking this heart rate, 70 beats per 1 minute. And we write it as a rate. And then we just gotta have conversion factor that changes minutes into 365 days. And we use these types of things here. These types of conversion factors. So I guess the way I think it's good to look at these is we're not going to jump straight from minutes to days or to years or even to days, because we don't know how many minutes there are in one day. But we can calculate it, right? And we don't know how many minutes are in a year, but we could build up and we could calculate it. So, if you're going to figure out how many minutes are in a day, what would you have to do to figure that out mathematically? What will you do?
Multiply 60 by how many minutes there are. Wait, what are we trying to find?
If we want to figure out how many minutes are in one day,
Oh,
What are you gonna do?
24 times 60
You got 24,
times 60,
what's the 24 from?
day.
Hours, good, units. Get units on every one of your numbers. 24 hours. So you gotta multiply by 24. Are there 24 minutes in a day?
No.
There's 24 hours.
Mm.
So we gotta multiply by 24. What else do we have to multiply by? 60 minutes in an hour. But we're at minutes already, so we don't need seconds. We don't need to go make it smaller. So let's put some of this in here. So you said there's how many minutes in 1 hour? So here's what you can do. If you say, well, I got 60 minutes in 1 hour, is the fraction gonna be written with hours on the top or minutes on the top? You can write it like that or as a reciprocal? Reciprocal, because if you do this with multiplication, you'll cancel the minutes. You see, and then, so when you cancel the minutes, it will now read this many beats per hour. So now we're up to hours. What's the next step? You said there were 24 hours in a day, so 24 hours in 1 day, what's gonna be on the top, days or hours?
Days on top, and then hours on, oh wait,
No,
hours on
hours.
top, cause then they cancel out.
Yeah, hours on the top, then they cancel out. That tells you where to put them. 24 hours in a day, so now we gotta multiply, and that makes sense, we gotta multiply a lot, don't we? And then we've gotta go 365 days, right? So, that's gonna be, call it a year. Then your days cancel. So then you just multiply these numbers all the way across. Everything is canceled out except for the years. So, pretty big number, isn't it? What is it? You got the calculators. And if you look here, we've got beats, and we've got a year. It's a pretty big number. 36,792,000.
Yeah.
There. So 36 million beats a year your heart does.
It still feels like very small.
36 million?
Mm.
Put it this way, you can't count that high in a year. Because that would be like reading a number a little quicker than 1 a second, 24 hours a day. And when the numbers start getting big, like 587,362, that takes like a second just to read that one number. You can't count that high in a year. And then you stand up and you run, or you walk up a hill and your heart rate goes up. Now you're beating faster than 70 a minute. So your heart, athletes are going to be 1.5 times this high. Athletes are going to be 50 million a year. You guys are probably 40 million or so a year at least. And then you're going to live how many years? 70, 80, 90? Yeah.
It would be like 140.
So let's just keep it real simple. Let's say it's 40 million times 80 years. It's that many million. Yeah, so your heart's gonna beat over 3 billion times in your life.
3 billion?
Over 3 billion times in your life. If you make it to 80, you guys probably will. Statistically, pretty good chance you're going to.
What's the average age that you die at?
For you guys right now, I don't know what it is. It's less than 80. the average age of death right now has actually gone down over the last year or so. It's the first time in recorded history that in the United States, the life expectancy has become less.
You also gotta count on what, like, why did they die? Like, was it natural causes or
Oh,
was it
yeah.
by?
Oh yeah, there's so many statistics that you can't shake a stick at them, there's so many. But our life expectancy has decreased over the last few years, and the reason it's decreased is because, why do you think?
Cause people are doing dumb stuff, like not eating good and getting on the drugs,
It's the eating,
alcohol.
it's the eating. It's not even drugs and alcohol, or, risky behavior. It is straightforward dietary. And we become less physically active. We don't see that as much living where we live, because by and large, there's a lot of activities that people partake in. But nationwide, people are sitting more, driving more, exercising less, and eating less quality food, which is rather interesting because we have the technology to have the highest quality foods in the history of time, as we know it. Yet people are eating crappier food. There's just like this crazy idea, yeah, McDonald's, but we buy these things at Costco, these, like the boxes of granola bars and the different things that you can get that come in the boxes like that. We buy those and we eat them. And Joan and I were sitting around the house the other night, and during social time, and she and I were just sitting and talking in the kitchen. We were having beer, we were snacking, and eating nuts and stuff like that, which we eat a lot of. And then we got into how many calories are in such and such. She's got these macadamia, chocolate-covered macadamia nut things that she likes to eat. And we looked at those, and it's like, they're macadamia and caramel clusters covered in chocolate. You'd think like big calorie load, right? Well, each one of those is 110. So if she eats 2 of them after supper, that's what she likes to do, that's 220 calories. And then we were like, how does that compare to a granola bar package? Like a 2-pack of Nature Valley granola bars? You know how many calories are in a 2-pack of Nature Valley granola bars? No, it's not that high, but it's 190. And then they do those, they're like Fig Newtons and Blueberry Newtons and stuff, and there's a 2-pack of them. You know how many calories are in 2 of those things? 210. But they're 110, but one of those Fig Newton things is the same number of calories as a macadamia caramel cluster dunked in chocolate. And we think of, oh, well, these are healthy, the granola bars are healthy, these Fig Newton type things are healthy, or these protein things are healthy. The Kind brand, kind of like a protein bar, 220 calories.
What do they use for these nuts, like the chocolate, for it to be lower than all of that?
It's just that they're in these things like granola bars. Read the ingredients. Sugar. It says whole grain rolled oats, and then sugar. They put so much sugar in that stuff, and that's your calories. What's that?
Syrup.
Syrup. Yeah, they use cane syrup, they use corn syrup, they use high fructose sweeteners. So we're jacking ourselves really high with carbs. Is there any garbage in there? Sometimes there's garbage in there that tells us that story too. Yeah, go buy a drink at the store. Well, what do you buy? Powerade, sugar. Gatorade, sugar. So,
I don't like the Powerade that doesn't have the bitter one. The other one's just tasty.
The fake sugar is not very good for you either.
no sugar in excess.
That's why coffee is bad for you.
Except it dehydrates you.
Cream in it, and that's
Hey,
That was a one-time thing.
here they say, explain why a train that's going 68 miles an hour is going about 100 feet a second. Explain why 68 miles
Oh my
per hour is the same as 100 feet per second. So when you see a problem like that where they're asking you to compare two rates that are in different units, you have to change one to the other. So we can change miles per hour to feet per second, or, which means that we'd have to change the miles into feet and the hours into seconds, and you gotta do it at the same time. Or you can do the feet and the seconds into miles and hours, but you gotta do both of them. So it's not that hard. Let me show you. I think I have a little bit more room here horizontally. So let's do the 68 miles an hour, and then write it like this. So even though you see the book showing it like that, or the problem, you gotta change that into 68 miles per 1 hour, okay? And in the end, we wanna get ourselves all the way to feet for the miles, and seconds for the hours. So we need to change both of them, but use fractions to only change one of the units at a time. So let's do the miles and the feet. What's the relationship between that? 1 mile is how many feet?
5,000.
280. Yep, the more we use that, the more you'll commit that one to memory. 5280. So if we write a fraction, how could we change that so that the miles become feet? We need a conversion fraction.
The reciprocal of that,
Well, we're gonna use these two in a fraction.
yeah.
So what's gonna go on the top, miles or feet?
Feet. And then,
So this is what we're changing.
yeah, cause don't you want the miles on the bottom so that it'll cross out on top?
Yes,
Yeah.
that's what drives this, is that canceling. Okay, so now that will change when you multiply to feet per hour. So then we just keep going, and we get our hours changed into seconds. So we gotta go in 2 steps though, right? Hours to minutes, minutes to seconds. So 1 hour is how many minutes?
60,
And 1 minute is how many seconds?
60.
All right, away we go. So our first one here is gonna work with that hour. So where do we put the 1 hour and the 60 minutes? This is the first fraction we're gonna be writing. What goes on top?
The 60.
If I put 60 minutes up here and 1 hour down there, then I have the hours times hours,
Alright, then we'll put the 100 up on top.
and the 60 minutes on the bottom. And then hours get canceled. And then this will become, when we're done, we have feet left on top. We've got minutes, but we have to change our minutes to seconds. So again, the minutes have to cancel, so we put it on the top, 60 seconds on the bottom. So this will do it. And we just have to do the arithmetic. So do your calculator, 68 times 5280. Hit equals. And then divide it by 60 times 60. But when you do that, you have to do the 60 times 60 in parentheses, I think. No, you can probably get away with it just going straight across. Yeah, you can just do 68 times
Keep the
5.
same number.
Yeah, it is the same. So what do you get?
35,
Oh, no,
hold on,
no,
359,000.
no, no, no. You haven't done something.
What do we do after we multiply it?
Here, you do 68 times 5280
Yep.
divided by 60 twice. You can do the whole thing in one line without parentheses. 68 times 5280 divided by 60 divided by 60. How much is that? 99 point something. 99.73 repeating feet per second. So that's why going 68 miles an hour is about 100 feet a second. Yeah, so 68 miles an hour, ooh, a lot longer than this room. Does about this whole length of this hallway in a second. 0, 1. That's pretty fast.
I don't wanna do it that fast.
So this kind of speed right here, when you're driving in the dark, on the highway, and you have regular headlights, you cannot react fast enough and make your vehicle stop fast enough for something that you see standing on the road within the view of the headlights.
LED fog light with 24 light bar on top.
Yeah, light bars makes a difference. But that doesn't do very good when Mr. Moose just decides to step up out of the woods.
Iron cross bumper.
Ask Natasha about that.
Oh yeah, she did that one, didn't she?
Yeah, she hit one, didn't she?
Oh, yeah, I forgot what it was.
So you're gonna look up your homework on